Hi, I'm Ms. Hall, and this is Lesson 6, Part A, Solving Linear Systems, 3 Variables. In Lesson 5, we reviewed solving a system of linear equations with 2 variables, 2 equations, 2 variables, and now we'll be doing 3 equations, 3 variables. The algebraic method you use to solve systems of linear equations in true variables can be extended to solve a system of linear equations in 3 variables. Here are the steps we'll be using. Step 1. Rewrite the linear system in 3 variables as a linear system in 2 variables by using the substitution or elimination method. Step 2. Solve the new linear system for both of its variables. Step 3. Substitute the values found in Step 2 into one of the original equations and solve for the remaining variable. Okay, so the gist of it is we first want to make it look like 2 variables with two equations with 2 unknowns. So we want to use the 3 equations we start with to get down to 2 equations and 2 unknowns. And then you solve how we solved in Lesson 5 for those 2 variables. And once we figure out what those 2 variables are, we can plug them into one of the original equations to get the 3rd variable. Lastly, when you obtain a false equation, such as 0 equals 1 in any of the steps, the system has no solution. When you do not obtain a false equation, but obtain an identity such as 0 equals 0, the system has infinitely many solutions. In today's lesson, we're going to see one of each case. We're going to see a system with 1 solution, a system with infinitely many, and a system with no solution. Example 1, solve the system. So I'm going to begin by looking at this system of equations and try to figure out which variable is easiest to eliminate. And because in this 3rd equation, y has a coefficient of -1, it makes it an easy variable to eliminate. Let me go ahead and label these equations as 1, 2, and 3. What I can do is I can pull over equation 1 and over here equation 2. So I have 4x plus 2y plus 3z equals 12. And I have 2x minus 3y plus 5z equals -7. Beginning with equation number 1. If I want to eliminate the y's, and there's 2 y's now, I want to manipulate the 3rd equation so it really has -2 y's. And how I do that is I multiply this 3rd equation, not that 3 as my label, by 2. And when I distribute that 2 to every term in the 3rd equation, I get 12x minus 2y plus 8z equals -6. And now when I add the equations, I'll be able to eliminate the y's. Let's look over on the right side. In order to eliminate -3y's, my goal is to get +3y when I manipulate this 3rd equation. So I'm going to manipulate the 3rd equation a different way. I'm now going to multiply it by -3. So I get -18x. I get +3y, which is what I wanted. I get -12z. And I get +9. And now when I add, I should put a plus sign here and a plus sign here, I will eliminate the y's. Let me go ahead and add these equations. I end up with 16x plus 11z equals 6. And I end up with -16x minus 7z equals 2. Okay, now I've eliminated the y's, and I have 2 different equations with 2 variables. Not to get confused, I'm now going to call this equation, let's call it A, and this equation B. And now I'm going to use what we did in lesson 5. I have 2 equations and 2 unknowns. to solve for both x and z. You can see by just lining up these equations, I'll be able to add them and eliminate the x's. So let me rewrite equation A. And when I add, so I didn't manipulate A or B at all, because when I add, the x's get eliminated. And I end up with 4z equals 8, z equals 2. That's good. Now I want to solve for x. So I'll use either equation A or B, because A or B just have z versus x, so I can plug in z. I'll use the one with all positive numbers. So I will use A as 16x plus 11 times z, which I know is 2, equals 6. 16x plus 22 equals 6. 16x. 6 minus 22 is negative 16. X equals negative 1. I know what x is, I know what z is, I don't know what y is yet. And this is when I go back to my original 3 equations, pick one of them, and solve for y. I'll look for one that only has positive values, because that makes it easier, which is equation number 1. So in equation number 1, it is 4 times x, which is negative 1, plus 2 times y, I don't know what y is, plus 3 times z, 2, equals 12. This is really negative 4 plus 2y plus 6 equals 12. This is really 2y plus 2 equals 12, which is really 2y equals 10, 2y equals 10, y equals 5. Now I have my 3 variables. I know what x, y, and z are, and if I want to write them in an ordered pair, I write them in alphabetical order. So it goes x, then y, then z. There's my solution. Example 2. I start with 3 equations and 3 unknowns. You say equation 1, 2, and 3. I am going to opt to eliminate the y's again, and I'm going to compare equations 1 and 2. So let me rewrite 2 as it is. And now my goal with equation 1 is to get negative 5y. In order to make those y's have a coefficient of negative 5, I need to multiply the entire equation by negative 5. I end up with negative 5x, negative 5y, negative 5z equals negative 10. Now I'll add these, and I know that I'm going to be eliminating the y's. Oh no, but at the same time, I'm eliminating the x's, so I have 0 x's. I'm eliminating the z's, so I have 0 z's. But I'm not eliminating the constants, I end up with negative 7. So here's a case where we end up with 0, nothing on the left side equals negative 7, which is never true. Therefore, this is an example of a 3-variable system with no solution. Example 3. I have 3 equations, 1, 2, 3, 3 unknowns. Looking this over, seems like this negative z is gonna be helpful because I can just add the first and second equation to eliminate the z's without manipulating or multiplying by anything, and I can just add the second and third equation to eliminate the z's. So let's pull over the first equation, x minus y plus z equals negative 3. My goal is to get a negative z. The equation already has a negative z, this second equation number 2. So I'll pull that over as is. And then I'll also be looking at the third equation. Oops. And I want a negative z. And I can just use that second equation again without manipulating it at all. Okay, let me add to eliminate the z's. So I get 2x minus 2y equals negative 6. And 6x minus 6y equals negative 18. I'll have what I call now equations A and B. Seems like I'll copy B. 6x minus 6y equals negative 18. And let me try to eliminate the, let's say the y's by having positive 6y, by manipulating equation A to have positive 6y, which means I will be multiplying A by negative 3. Negative 6x plus 6y equals 18. Add this together, I get no x's plus no y's equals 0. In other words, 0 equals 0, which means there are infinitely many solutions.